this start streaming thing yet. Forgot to click the button. There we go. There you go. Alright, so I think the live stream is up now. Yep, there we go. Okay, sorry about that. I totally forgot to turn on the YouTube side. Let's see. Do not share or discuss any part of the exam with anyone in class or otherwise on the day of the exam. This is because some people may actually get DSPS accommodation, so those people may still be in the exam when most people are out of the exam. So just kind of don't talk about it with anyone on that same day. Grading is based on explanation and steps, demonstration of understanding of knowledge and problem-solving skills, and not so much the final answer. In other words, I want to understand how you get to the solution. So the more explanation, the better. Sufficient explanation means your answer connects definitions and concepts that we talk about in class using logical steps to get to the answer or the solution of a question. Write your answer in the document right after each question. So basically, because it's a Google Doc, you can always just kind of press the enter key and make the space for your answer. Do all your text editing in document. Do not copy and paste from an outside source. This one I think I am not going to allow this semester because it really makes grading very, very difficult, is to have people to take a picture of a piece of paper and then paste it into Google Doc. That just doesn't work out very well for me. So I think I am not going to include this option this semester. And then usually I will tell you how many questions there are and that they carry equal weight. So are there any questions about the instructions? Basically, on next Monday, shortly before 5:30, I will share a Google Doc with you. And typically for most people, that means you'll receive an email indicating that you have a document being shared with you. Now that document can only open after you sign into apps.losrios.edu. So, you cannot access it from any other Gmail account. And I am not going to share the document with any account outside of the Los Rios edu. So you just have to remember to sign into apps.losrios.edu first. Yes, we are going to type the work or your answer into the Google Doc. So that should answer Chibuzo's question. Next one is, so we can't do scratch work on the piece of paper and then scan them as PDF. Yeah, that is correct. Now, if you want to show me scratch work, that's fine, but I want to use only typed answer for grading purposes. One of the reasons is because I might want to write a script to auto grade some of the questions. And if it is on a piece of paper, and it's scanned, then I don't have a way to do that anymore. Use equation on Google Docs. You have all the symbols. Yes, and for the most part, the symbols that we use in this class for set notation, most of those are not even special, right? It's just that when you have a union or the intersection or subset of, then they're kind of special. So the question itself does require the use of the symbols, but not so much your answer. We'll see. I mean, you guys will take a look. We'll take a look at the practice test, and it will be clear. Any other questions about the format of the exam? Okay. And I want to. Oh, okay. Here comes another question. Oh, okay. Oh, okay. I see. All right. So we're gonna get started with question 1 of 7. So the first part of this explains what this notation means. X gets Y is an assignment. I don't want to use equal because equal can be used for comparison. So instead of using the equal symbol, which can be misunderstood as equality, I'm using the assignment. So X gets Y is an assignment, which means the value of X becomes the same as that of Y. Given that X is a set of 0, 1, 2, 3, Y is a set of 0, 1, 2, 3, and F is 0, 2, 1, 1, 2, 0, 3, 0, answer the following parts. So there are several parts. And there's an instruction, or there's a grading criterion specified here. You are to minimize changes to xi, yi, and fi to answer the other parts. Maximize the cardinality of the intersection of f, f0, f1, and f2, and minimize the union of the set f, f0, f1, and f2. So that is important because in spring a bunch of people did not really, they completely ignored this particular grading criterion, and they just go for the simplest and the most obvious answer without addressing this particular criterion. In the first three parts of your answer, specify only the changed fi, xi, and or yi, which means if something does not need to be changed, you don't have to rewrite the content. You can just say same as before. Also include a short explanation why you make the changes. So if changes are necessary, then you have to explain why you need those changes. If a set is not changed, do not mention it in your answer. There is no need to use subscript in your answer. So that makes typing a little bit faster for you, because instead of typing f underscore 0 in the equation, you can just type in as f0. Okay, so that means typing is fast. No, f0 is the name of a set, as we will find out here. The questions actually tell you what it is. Alright, so start with f0 gets f, x0 gets x, y0 gets y. In other words, I am using x, y, and f as specified here to initialize the variables f0, x0, and y0. f0 is a set, and after the assignment, it would be the same as f, and x0 will be the same as x, y0 will be the same as y over here. So everything gets reset, back to the original definitions of x, y, and f, but I make new instances so that you can modify the instances per question. Make minimal changes potentially to f0, x0, and or y0, so that f0 will now be a function using x0 as a domain, y0 as a codomain, and we want to make it injective but not surjective. Alright, so we'll take a quick look here and find out how to do this. I'm going to use a plain text editor to record my answer, just to show you that it's really easy to type your answer in using just the normal keyboard. You don't even need equations to do this. I know Jonathan wants to use equations, but it may not be 100% necessary in this case. Alrighty. And there we go. So what I'm going to do is I'm going to get the initial value first of x0, which is 0, 1, 2, 3. So they all three parts start with this start with the same premise. So we have x0, y0, and also f0 to be initialized based on what is given to you at the very beginning. Now in the actual test, guess what? You can copy and paste, because copying and pasting within the document is allowed. So copying and pasting from the question itself is not a problem. Just select, Control C, move the cursor to where you want it to be, and then Control V, you're all done. Alright, so now we have to focus on what we actually need to do. So we want to make the minimum changes, and we want to make f0 a function so that it is injective but not surjective. Alright, so let's take a look at f0 at this point and see whether it is already injective, because guess what? If it's already injective, I may not need to do anything. So I want to check. So 0 maps to 2, 1 maps to 1, 2 maps to 0, 3 maps to 0. It's not injective because we have two elements from the domain mapping to one single thing in the codomain, but it is a function because there's a chance that it may not even be a function, so you have to fix that too if it is not a function already. So now we have to find out why it is not injective. and it's not injective because we have 2, 0, 2 mapping to 0, 3 mapping to 0. So there are several ways to fix this problem. But since I'm looking for the minimal change, so the minimal change, does anyone want to use Tosh? I can hear you.
Sorry, my bad.
No problem.
Oh. Oh.
All right, thank you. All right, so so we find out that two of all the elements of the codomain, 1 is used, 2 is used, 0 is used, 3 is not used. So one way to modify this is to say, we're gonna modify F0. Okay, so we'll copy and paste it here, and we'll change F0 to map 3 to 3. Okay, so changed so that the function is injective, but I'm not done yet. I'm not done yet, Jonathan. and then I'll make changes to y0. So I'm going to make a change to y0, so it has 0, 1, 2, 3, and 4. Okay, changed so that f0 is no longer surjective. That's it. Okay, so that's my first answer. And then for the second part, it's really the same format. Reinitialize, basically reinitialize. Well, I shouldn't say reinitialize because we actually get a new set this time. This time is f1, x1, and y1. So in your test, you can copy and paste. So just copy and paste, change all the zeros to ones this time, and we'll try to modify these things to satisfy the requirement that is stated in the question. Do we have to specify the changes we made and why, or just label the work as you have done here? I did explain. I did explain that the function is now injective, and this change is to make f0 no longer surjective. No, you don't have to mention 3-0 got changed to 3-3 because I can probably spot that myself. So that's going to be okay. No. No. Part 2 does not reuse. Remember, Part 1 uses x0, Part 2 uses x1. Read the question carefully. The subscripts have all been changed from 0 to 1. Yep. So my suggestion is to read the questions really, really carefully. Every semester, somebody would tell me, your questions are very confusing. And most of the time it's because someone did not read the question entirely or they miss out a few really important keywords. So my suggestion is to read them really carefully. And if you do not understand fully what the question is asking, or you think there might be several ways to interpret the question, always ask me using the direct channel in Discord. Alright, so this time we want to make minimal changes, but this time we want it to be a surjection but not an injection. Okay, so let's take a look. We want it to be a surjection, which means everything in the codomain are used. So if you look at it right now, we are not using everything in the codomain. But but we don't want it to be an injection, which it is already not an injection. So this one is rather easy. Because I can change any one of the three, right? I can change x1, y1, or f1, or multiple ones at the same time. This time I'm just going to change y1. Instead of having 0, 1, 2, and 3 in y1, I'm just going to say, well, anything that is actually mapped to from f1 stays in y1. The only one thing that is not mapped to, which I think is element 3, is gone. So by doing that, changed so that f0 is no longer so that it is an injection. All elements in y1 are mapped to. There we go. I'm not sure what Aman is asking. Is surjective for 2? Not. I'm not sure I know how to answer that question. We want it to be surjection, a surjection. By removing element 3 from y1, I don't have to make a single change to f1. It's a surjection already once I remove 3 from y1. And Jonathan is typing, so I'm going to wait a little bit. Why did you put F0 and injection? Hmm? This is question number 2. I'm trying to answer question number 2, and these are all have a suffix of 1. Change so that F1 is a surjection. Yes. I changed Y1 so the F1 becomes a surjection. You put so 0 is an injection. Yes, F0 is its own set. F0 is a set, F1 is a set. They are not the same. They don't need to be the same. You put F0 and injection for 2. Oh, okay, I see. Okay, on this line. Thank you. All right, my bad. Okay, I just didn't quite understand what you guys were saying. Okay, I mistyped F1 instead of F1. I typed F0. Thank you. Okay, very good. All right, moving on to the third part. So the third part has basically the same setup. So once again, we initialize the 3 new variables, each one being a set. This time we have f2, y2, and x2. So all this time we have to keep in mind that we want to make the minimum changes so that the intersection of all the f's is going to be maximized, and then the unions will be minimized. So we have to keep in mind that that's the objective. Let's see. The question is also injection should be changed to surjection for 2. Oh, right. Yep, there we go. All right, thank you. All right, so let's look at part 3, which is spilling over onto the next page. So we want it to be a bijection this time. Okay, so we want F2 to be a bijection. So what is the laziest way to turn it into a bijection? I think I'm going to go for this solution over here. Okay, so I'm going to change F2 so the F2 has 0, 2, 1, 1, 2, 0, and 3, 3. So that F2 is a bijection. Yep, so Jonathan is correct. So this way, I'm making absolutely, well, I think absolutely the minimum changes to satisfy the constraints of each part of the question. So 4 and 5, parts 4 and 5, it's asking you about the intersection and also the union. So we'll go ahead and specify that. All right. All right, so there's a comment, every element in codomain is mapped to and each mapping is unique. Yes. Yep. So the key is uniqueness and everything in the codomain are used. All right, so let's work on, oh, I lost my PDF. Okay, come on. There we go. So now we want to find the intersection. So we'll say intersection. Now you don't have to do the intersection because you can just put the set, specification right here. But I want to relate my answer to what the question is asking. So the intersection is going to be a set, right? So we have 0, 2, 1, 1, 2, 0, 3, 0. That's coming from both F1 and also F itself. And then we have 3, 3, which is coming from F0 and also F2. All right, so that is our intersection. And then I take it back. Sorry. Okay, I worked out the union. This is the union, not the intersection. This is the union because anything in the union can be found in at least one of the components of the union. Now we work on the intersection. So the intersection contains everything that is common to every single set that we mentioned. So 0, 2 is common to everyone, 1, 1 is common to everyone, and then 2, 0 is also common to everyone. And that is our intersection. There we go. Yeah, it was me, Adam. Um, yes, we are supposed to maximize the intersection and minimize the union. And this is how we can do it. I cannot think of a way to make the intersection any larger while keeping the union as small as possible. Three, 3, so it can't be in the intersection. That's right. So after the correction, intersection does not have 3, 3 anymore. So Adam is correct. Does minimizing changes meeting the condition always maximize intersection and minimize union? Yes. So when I said, minimizing the changes, that's just English. So the technical way to specify to minimize the changes is to maximize the intersection and minimize the union. There we go. How would that thinking work in a test for maximize minimize? Will we just make as little changes as possible? Yeah, that's the whole idea. Make minimal changes. This is like a hard lead code elite, I guess, code problem. What is the maximum minimum number of steps to do blah? Yeah, I think this time it is, these are not really that difficult. All right, so what is up next? We want to find the difference. So we want to find things that are in F1 but not in F. So we look up F1, and F1 did not need to be changed, so that would be an empty set here. Everything in F1 is also found in F. That's basically what we are talking about here. FLC++ sigma grind set. I'm not sure what that is, but I'm guessing it's a tough problem for people to solve. Well, the live stream doesn't capture the text channel, but sometimes I do read it out. Oh, okay. So Folsom Lake has a club for tough computer science problems. Is that kind of what it is? Okay. Well, that's kind of cool. That is kind of cool. I think doing that sort of stuff it will definitely help people getting ready for job interviews, because that's what employers are shifting to these days. Is they don't really value your GPA as much anymore, nor where you graduate from. Basically, your diploma, your bachelor's degree, is nothing more than meeting a minimum requirement, and to compare you to all the other candidates, they're going to have their own programming contest basically, um, to assess the technical strength of all the candidates. All right, so moving on, we got 6 already. Now we're moving on to 7. So 7 is to evaluate a particular quantified statement, and it says for there exists an some element A in F0 for all B in F1. A does not equal to B, and we want to evaluate and we want to explain the answer. All right, so the first thing is to find out what is that asking for, right? So it's basically asking, can I find at least one value in f0 such that for everything in f1, that thing in f0 does not equal to everything that you can find in f1. In short, it's asking, is there something in f0 that is not in f1? That's what it's asking. Okay, so we're gonna answer that question. So f0 is this, and then f1 is this. So 3, 3 would be an element, so we can now answer the question. So we can say, when a equals to 3, 3, um, it does not equal to anything in f1. And of course, we can make it slightly more clear. This is in f0, and it does not equal to anything in f1. So the expression itself is true. There we go. So let me see what questions are coming about this particular answer. Do we need to specify we think expression means in 7? Um, you don't have to explain that, but you do have to explain, why you think it is true or false. So this will suffice, okay? If you find one, it depends on what the question is asking. If it's asking for there exists and the answer turns out to be true, then you can just say, hey, I found this one thing, at least this one thing that satisfies, this requirement. But if the question is saying for all, okay, then you can basically say, I cannot find anything that does not satisfy the requirement, and therefore the answer is true, that sort of thing. Isn't that just f1 a subset of f0? No, it's not the same thing. Because this one is really just asking, whether there's something in f0 that is not found in f1. At least one, yeah. But it doesn't say for everything. So that means f0 and f1, they can be different. In other words, they are not subsets of each other. Okay, easiest case, okay? Think about f0 only having the element a, and think of f1 only having the element b, okay? And this statement will still be true, right? Because, something is in f0 that is not in f1. Does that answer the question? I mean, do we still have questions about number 7? All right, so let's take a look at another example. Kind of not related to how we define the f's here, okay? All right, so I'm going to redefine f0 to be a very simple set, right? So I'll define this one as 1, 2, and I'll define f1 as ab. Okay. So if this is how I define f0 and f1, obviously these are no longer functions whatsoever. However, I just want to evaluate this particular expression. So what is the value of this expression if I define f0 to only have 1, 2 as elements and f1 only having ab as elements? It'll still be true, exactly. So Jonathan is correct. The answer will still be true. Neither is a subset of the other one. In fact, they have an intersection of absolutely nothing. And none of the set itself is empty either. They're just totally unrelated. Because the question is simply asking, can I find something in f0 that is not found in f1? That has nothing to do with whether one is a subset of the other one or not. This kind of question is designed to test whether people understand the quantified expressions. and the quantified expressions were explained using C code, using C code control structure. That is how people need to get back to in order to fully understand what existential and universal quantification means. All right. All right, so Adam is saying, yeah, but if F0 contained no element not in F1, then it's a subset of F1, isn't it? Um, let's take. Okay, so let's take a look at that particular instance. Okay, I'm changing the example so that F0 is an empty set. If F0 is an empty set, then there's nothing in F0, right? So if F0 is an empty set and I'm doing a quantifier like this, I don't even need to know the rest. It has to be false. I cannot find a thing in F0 such that blah 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 because there is no thing in F0. So I would advise people to go back to how I explained the universal and the existential quantifiers using C code, because that is basically linking the abstract concept that we are talking about in this class to something that you already have used quite a bit from CISP440. So I would definitely go back to that sample code. Yeah. Okay. Cool. All right. So let's move on to additional questions. So question 2 basically has exactly the same format, except F starts with a slightly different, uh, you know, it has a different set of, F is a different set of elements of the Cartesian product between x and y. And fast forwarding to question number 3, same format. Fast forwarding to question number 4, same format. Number 5, same format. 6, different, and 7 are different. So let me get to question number 6 first, and then I'll go back if people want to do another example. Okay, would that be okay? Because otherwise it will be kind of mind numbing. All right, cool. So I'm just going to do question number 6 first, and then, depending on how people want it, we can go back and do question number 2, or whatever question you guys want me to get to. All right, so question 6 of 7 is asking the g function defined in the aleph no module. So first thing is you need to have a quick way to get to a module quickly in the exam. Okay, the exam is not closed book. Okay, it makes absolutely no sense to make an exam closed book. Not only because it's online, all my classes when I was teaching face to face, all the exams were open book and open notes as well. Because when you're working as a developer or when you're working as a computer scientist and doing research, do you think there's a requirement of you cannot hook up to the internet to do your research or do your coding? That would not be reasonable. Okay, the only type of occupation where you kind of have to say, I think you really need to have everything memorized and not rely on the internet while you're working. There are very few occupations like that. A surgeon is one of those, because you don't want a surgeon in operation asking nurse, iPad, go to Wikipedia, look up this term. Where is that little artery that I'm supposed to find? That may not be very good, when you're a surgeon, that you have to get onto the internet to search for a particular artery while you're in operation. Okay, I get that. Okay, but as a computer scientist, as a developer, as a software engineer, you probably have access to the internet. Okay. Um, that's a very good question, Wilson, because I lived through that era. I am that old. It's not a big deal. I mean, most programs come with some form of online help. So when you install Borland C++, okay, it has its own online help that is also installed. We got books, right? So for the most part, we can still dig through stuff, references and whatnot. You just cannot get someone else to help you or look up, the answers that someone else has already figured out. Nope, trial and error would not be a very good idea. You just have to look up things and try your best to understand as much as you can. All right. Well, things were moving slower, hence affording better documentation. These days, the revision of stuff is just so fast that documentation is always lagging behind. So that's kind of the deal these days. All right. So getting to question number 6. All right. The G function defined in the Aleph No module can be used in a nested fashion to fold any discrete finite dimension space to the line of natural numbers. In this question, define k as a function. It is mapping the Cartesian product of 3 natural number sets to just one single natural number set. And we're defining k using G, so it's a nested definition here. Show the step-by-step computation of this function g to the coordinate of 4, 9, 5. I think this one is a fairly easy question to answer because it's really just kind of plugging in the values and figuring out the answer. So the way to answer this question is to say the k value of 4, 9, 5 is, so the definition is already here, but you have to be careful where the z and the y and the x are located because they are shuffled. Okay, so y is 9 in this case, and z is 5 in this case, and x is 4 in this case. Okay, there we go. So now you expand it a little bit more, right? So whether you expand it from the outside in or inside out is up to you. My usual approach is to expand from the inside out. So to expand from the inside out, this time we got 5 plus 4 times 5 plus 4 plus 1, the whole thing divided by 2, plus y, which in this case is 4. So we are plugging that value into the whole thing. And then let's go ahead and actually do the calculation here. All right, so here we got 20 times 21. Oh, nope, never mind. I misread my own operator here. So it's 9 times 10 divided by 2, so that's 9 times 5, which is 45. 45 plus 4 is 49. So we got a 49 here. And now we just have one more level of g to resolve. So this time it is 9 plus 49 times 9 plus 49 plus 1, the whole thing divided by 2, plus the y, or the second number in the 2 tuple. And this becomes, okay, so it becomes 58 divided by 2, which is 29, times 59, and then the whole thing plus 49. And you can just do your quick math. I mean, I'm just going to use a calculator off screen to do this. 29 times 59 plus 49. That turns out to be 1,760. Okay, there we go. So this is 1,760. So that is what I mean by step by step. You expand one level of the application of the g function one step at a time, and then we get to the answer at the end. Alrighty, moving on to question number 7. So question number 7 is not the same as question number 6. It is the reverse. So question number 7 is starting with k of 527 is 1, 3, 1383, and I want to reverse the process to find out, how G is used in a hierarchical way to define K. Okay, does everybody understand what what the question is asking? We know we know one instance, okay? K of 527 is known to be 1383. But what is not given to you is the actual definition of K using a nested application of G. So we want to find out exactly how G is nested in order to find K. Yep, we're going to use G inversed to come up with, to help answer this question. So the question is, how are we going to use G inversed to help answer this question? So basically, I'm just going to describe the steps here because I don't have G inversed. Well, I suppose I can show you how to do that too. So the general approach is look at this number and apply G inverse to it first. Okay, so when you apply G inverse just once, you're guaranteed that one of the two numbers resolved by applying G inverse on 1383 is going to be one of these three. Okay, so you'll get 5, 2, or 7 as one of the components. So that will lock down one single component. Whatever is left is going to be a larger number, and then you apply G inverse again so they can resolve again and find out which two of the remaining, how they're organized when you apply G inverse in a nested way. So that's the general method to solve this problem. Let's go ahead and solve the problem. Do you guys want me to solve it, or do you think, yeah, we get it, we know how to do it? Okay, so let's go ahead. Alright, so once again, it is important for you to quickly go back to the notes. So we get back to Aleph Null, and then we apply, look up the G inverse function, which has a subfunction of W. So we defined W as a function first right here, and then we apply that over here to resolve the x and the y. Alright, so now the question is, I'm in an exam, and how do I speed up this process? Well, using a spreadsheet can be helpful. Now, I'm not asking you guys to come up with a spreadsheet for every possible scenario because that is just not possible. Okay. However, knowing how to use a spreadsheet is going to be helpful. It's not a requirement because some of you probably feel more comfortable with a scientific calculator. That's fine too. Let me use a new spreadsheet and resize it here. There we go. Alright, so here's a spreadsheet, and I am going to use one column to specify the parameter n. So, I'd like to document my stuff. Okay, so we'll say this is the first element. Oh, this is wn. Yep, okay, so we'll need that. The first time, the first row is going to use, oh, where's the question? The question is here. So we got 1383. Okay, switch back to the spreadsheet. 1383. And I want to define W of n using a formula. Okay, so this way I can reuse the formula again. So we'll go back to the definition over here and take a look at Wn, what it's going to look like. So now I'm going to define it as the floor. I'm really just literally translating what is in the module into a formula in a spreadsheet. So this is the floor of the square root of 8 times whatever n is plus 1. And then we take the square root, subtract 1 from the square root. And then we also need parentheses here from here to here, because we have to divide the whole thing by 2, and then we take the floor of that. There we go. Cool. So the first time we apply, W of n, we get a 52. So now we want to find out, once we apply G inversed to n, what is going to be the x and what's going to be the y. So this is going to be G inverse of n, and this is the first component, which is the x component. So we'll copy and paste, and this is going to be the second component here. So we will, this time we'll use this equation here. So it's basically W of n, which is, oh, we're gonna need the parentheses, because we have to divide the whole thing by 2. So open parenthesis, and then we have Wn times W of n again plus 3, and then the whole thing divided by 2, and then minus n over here. And I think that should be it. So it turns out x is 47. And then on the other side, okay, we got a text message coming in. Yes, so bracket 0 is the first element of the 2 tuple, and bracket 1 is the second element of the 2 tuple. That's kind of, my lazy notation to refer to different parts of a 2 tuple. Alright, so this one is n. This is n minus Wn times Wn plus 1, close paren, and then close paren one more time, and then the whole thing divided by 2. So it's 47.5. And we take the 47 and we say, okay, what about using 47 as n? What is that going to do, right? 47 is here. And if you think that I'm going to re-enter, all 3 complex equations at this point, you don't know me. Because that is what I'm going to do. All right. So now, how do we look at this? Okay, where's our answer? Okay, so the answer is okay. Let me get back to the question first. Give me a second. Switch back to the question, and then we can relate the question back to the answer. There we go. Okay, and then we'll position things around here, and then put this over here so we can actually get to see the spreadsheet and the question at the same time. All right, so what do we know? So we know k of 5 to 7 is the g. So we take the first row here. We know it is the g of 47 and 5. So we know it's the g of 47 and 5. And how do we get the 47? It is the g of 7 and 2. There we go. All right. So given I can now re-express k of 5 to, 7, not 8. Typo. There we go. So now that we know that we can express k of 5 to 7 as the nested application of g of 7 to and then 5, we just have to find out, which one is x, which one is y, and which one is z, right? So this is x, 5 is the x, 2 is the y, and 7 is the z. So that becomes the general equation to get to k of x, y, and z. Is that okay? Does everybody understand the process? All right. Oh, okay. So let me see if I can answer Jonathan's question. So this 9 is not part of the answer. The answers are in column C and column D. The 9 is just W of n, which is a intermediate step that I need in order to figure out the x and the y. So 9 is not a part of XYZ. It's just, helpful in the process to find XYZ. All right, excellent. Any other questions? You guys cannot hear that in Discord. I just played the soundtrack of the cricket. I like that question. What are we going to do on Wednesday? We are moving on to new topics, of course. Oh, you heard it. Oh, okay. Hmm, interesting. Um, we are going to finish up relations. Yes, we're going to finish up relations because we were just about to talk about anti-symmetric, which is one of the most confusing characteristic of a relation. So we'll move on to that one first. Once we finish up relation, which I think we can do on Wednesday, then we're going to move on to talk about propositions, propositional logic. And you might have some exposure to propositional logic. I know someone in this class already has some exposure, but the way I explain propositional logic is very different from other classes because I have a focus on what is useful in computer science and not the general propositional logic intended for human consumption. So there you go. All right. I'm guessing Armand just heard the cricket. All right. So now we can. Do we want to get back to the earlier type of questions, because they all look about the same. I mean, it's just a matter of, what the original set looks like and what we want it to do. Um, so do we want to redo those? Like look at another one of those examples. Okay. I don't have another question like Q7. Um, it's about the approach. I mean, oh, okay. I take that back. I take that back. Take the solution of question number 6 and turn it into a question for number 7. How about that? Yes? All right, cool. Okay, so do you want me to do it or do you want to do it yourself? Because if you want me to do it, it's going to be pretty lazy. Do you want me to do it? Okay. All right. So I have to laugh. Yeah, I have to kind of snicker a little bit because um, I think my solution to this problem is going to be it's going to look a little bit terse. I'll just put it that way. Okay. So we start with the solution of question number 6, which is 1060, and then we go to the spreadsheet like here, and we just plug it in like that. Yes, plug it in. Nope. Oh, wait. Was that the number that we had? Nope. 1760. Okay, never mind. Okay, let me retype it. 1760. There we go. All right. So now that we have 1760, we can see how we got the 9 as the first component. And then the 49 is the big one left. So we plug the 49 back into n to solve it into 5 and 4. So now we know how the whole thing is nested. So the original one is 495, and what we found out is the 9, which is the y, is the first one of the outermost application of G, and then the second component of the first the outermost level of G itself is an application of G with 5 and 4. So that means it is Z and X as its components. Oh, it's easy to be slower. You can just replay the YouTube video and slow it down. What you really want me to do is to explain the rationale. The rationale has to do with this is starting with n. This is W of n as defined in the module. This is the x and this is the y after we apply G inverse. So how we got these functions, how we got these formulae is coming straight out of the notes. So if you go back and check the modules, let me go back to the module here. So when you go back to the module, this is how Wn is defined. This is how we get to the x component. This is how we get to the y component. And this is how G inverse looks like, because G inverse of n is going to give you a 2 tuple. Okay? So that's how I set up the spreadsheet. So what we do next is we plug in the n so that we end up with the first item of the 2 tuple and the second item of the 2 tuple. And we found that this 9 is matching one of the numbers in the three-dimensional coordinate in the question, because in the question we have a 9 here. So we know that the y component of the original three-dimensional space becomes the first parameter or the first item in the 2 tuple in the outer application of G. The second component of the outer application of G is 49, which does not match one of the digits that we started off with. So that means we have to reverse that using G inverse again. So I put it over here. This is the Wn when n is 49, and this is the first component of the 2 tuple of the solution of G inverse, and this is the second component of the 2 tuple after we apply G inverse to 49. And we can see the 5 is corresponding to the Z, and we can see how the 4 is corresponding to the X. So now we have clearly identified, the X, Y, and Z coming from the original application of K, and we got back to, how G was applied in a nested way to compute K. So is that okay? I mean, does that help? Okay, all right. Yes, rewatching always helps. Before you rewatch, it might also be helpful to review the material yourself first, because otherwise, you won't be making connections between the terms that I use, like what is G inverse, what is W of n. All of those things are in the module, but if you don't read the module first, it might be difficult to associate those terms so that they make sense. So there we go. All right. What are we gonna do next? The time is 7:30. We got 20. Yeah, we got 20 minutes left. Yeah, it's 5:30. We got 20 minutes left because the class ends at 5:50. Take row. I didn't prepare to take row today, so you guys all get a free pass today. Woohoo! I mean, people who are missing the lecture, unless they really watch the video, they're gonna miss out a lot. We can cover 2 to 5. All right, if you guys insist. Because going through these questions 2 to 5 is like chewing styrofoam board. I mean, you guys will get that sense too, because once you have figured out one or two, the rest are really about the same. Okay, they have there's slight variations, here and there, but not a whole lot. Oh, one thing I want to point out, not that it is actually important to anyone, is typically I design the test so that no two-person in the class would get the same question. So these are all variations generated by a program, um, and I just randomly assign these questions to people. How many do we have to get right to pass? Well, that goes back to the scale, right? Do you remember the scale that we mentioned, in the syllabus? Yep. So in terms of point values, okay, in terms of point values, to pass the class is 37.5% or more. But I do grade the answers based on the A, B, C, D, F, ranking. In other words, I look at every single answer and I think of, rating a product from Amazon. 1, 2, 3, 4, 5 stars. 1 star is an F, 2 stars is a D, 3 stars is a C, 4 stars is a B, 5 stars is an A. That's how I grade, and that's how you're going to get your grade assigned at the end of the semester. That percentage is in the syllabus. So you might want to either read the syllabus or watch my discussion of the syllabus. So Jonathan is asking, what if we get a wrong and B, C, D, E, F correct approach-wise? What if our approach is correct for the ones after A? So that's a very good question. I evaluate based on whether I see evidence of the person being able to understand the question and being able to find the answer. So I do give partial credit, and I differentiate between a perfect answer and an answer where almost everything is right except for some minor little detail. Okay, usually it's an omission instead of a mistake. It's like, okay, should have mentioned this also. But it also covers like minor mistakes. Okay, things that I can see like, oh yeah, it's a typo, because I make typos too. Okay, making a typo should not fail me. I might get a B instead of an A. So there's that. A C typically means something more than a superficial thing. Okay, it is probably a misunderstanding of something or a pretty serious mistake in the application of something, but still nonetheless has enough evidence that that person understands the concepts enough. Okay, so don't ask me what is enough. It is kind of subjective. Okay, I try not to be subjective, but it's difficult to avoid subjectivity when it comes to grading open-ended questions. A D means, yeah, there's an answer. The answer seems to have something correlating with what I'm asking, but there's insufficient evidence that this person understands the concepts. And F is easy. Either there's no answer whatsoever, or it's entirely wrong. There's not a shred of evidence whatsoever that the person who answered the question understand the material. So that's how I rank A, B, C, D, F, or if you prefer using the Amazon scale, 5 stars all the way down to 1 star. So any questions about that part? Okay. All right. So let's get to question number 2. Yes. Crickets. Crickets. They are pretty tasty too, actually. Now I'm hungry. I want my dinner. I want crickets. All right. So there we go. I just copied and pasted from the question itself. And let's tackle question number 1. So for question number 1, we want f0 to be a function and we want it to be a bijection. All right. So obviously this time, we cannot just use f because f is clearly not even a function. So the first thing you might want to ask yourself is, why is f0 or f itself not even a function? Let me see. 1 is mapped twice from the domain. That makes it not a function. Yep, so Jonathan is correct. Other than that, it's okay as a function. If I just get rid of one of them, life is good. All right, so what do I do to make it a bijection? Which means, first of all, it has to be a function, but it also needs to be injective and surjective. The easiest way to do this is to get rid of this guy. So f0 is now a bijection. Let me double check. So we want the everything in the domain appear once and only once as the first component of a two tuple in the set. We got 0, 1, 2, 3. Okay, that's good. It is a function. Is it injective? We have 1, 3, 0, 2, being the elements in the codomain to be mapped to. It is injective because it is unique. Is it a surjection? In other words, did we use up everything in the codomain? Since the domain and the codomain have exactly the same cardinality, once we establish it is an injection, it is automatically a surjection. So it is definitely a bijection at this time. All right. And then we're going to move on to the second part. All right, so once again, copy and paste first. I think we don't have to copy and paste until we know what we need to change. Okay, so we'll defer that copy and pasting. This time we want it to be a surjection, but not an injection. Not too hard. So F1, the way it is right now is not even a function, so we need to make some changes anyway, even just to make it a function. So we might as well use that chance to turn it into a surjection, but not an injection. So now it is not an injection because map is mapped to twice. There we go. But we have another requirement, right? We still want to make it a surjection because as it is right now, it is not a surjection because nobody maps to 3. Okay, so we need to change y so that 3 is no longer in it. Then it becomes a surjection. So 0, 1, and 2 can stay, but 3 cannot stay there anymore if we want F1 to be a surjection. All right, next. What do we want? We want it to be an injection, but not a surjection. Okay, that's not hard. We are going to recycle this guy. Okay. But we have to rename it because every single one it needs to be used later on to compute all the intersection and unions. So F2 is going to be this. Okay, that makes it an injection, but we don't want it to be a surjection. Okay, well, if you don't want something to be a surjection, easy peasy. Just add something to the codomain so that it becomes not a surjection. Okay, so we got 0, 1, 2, 3. Just add a 4 to it, and we're done. All right, next. Oh, this is Y2. Sorry about that. Forgot to change the suffix. There we go. All right, so now we move on to part 4, part 5. So part 4 is to find the intersection. So we just say intersection is. So that would be all the common ones. So 0. Okay, this is going to be a set. Okay, so start with a set curly brace. And then 0, 1 is in every single one. 1, nope. Okay, 2, 0 is in every one, and then 3, 2 is also in every one of F0, 1, F1, and F2. Then the next one is to ask about the union. So the union is going to include at least everything in the intersection. So lazy as I am, I'm going to copy and paste. And this is perfectly okay in the test as well. As long as you're copy and pasting within your own document, it's not a problem. All right. So, but it also has to include everything that appears at least once in one of the four sets. Okay, so we have 1, 3, and we also have 1, 1. So we just have to add those two in, and now we have the union. All right. The next portion asks about what is f1 minus f. All right, so f1 minus f is asking what is in f1 that is not in f. Or if there's nothing, we can just say it's an empty set. Let's take a look. This is f1. This is f here. Everything in f1 is in f. So this is an empty set. There we go. And then for number 7, it's the same thing. Okay, so in spring, every single question asks basically the same thing. So the structure turns out to be identical. I would advise you not to make that assumption unless, in the exam I say specifically the structure of question blah to blah are exactly the same. So if I don't say that, don't make the assumption, and read the questions carefully. So I would read it carefully. There exists A in F0 such that for all B in F1, A does not equal to B. That is the same as the first question. So we are asking, can we find something in F0 that is not in F1? All right, so let's take a look. This is F0, this is F1. Okay, so we found here 1, 3 is in F0 and not in F1. So we'll go ahead and explain why that is the case. Okay, so the answer is true because 1, 3 is in F0 but not in F1. There we go. All right. Yep. So Jonathan is giving a even more complete answer. 0, 1 does not 1 3 does not equal to 1 1 does not equal to 2 0 does not equal to 3 0 does not equal to 0 1. So that would be even more complete as an answer, but the way it is right now is okay too. All right, so that's question number 1. Question number 2. Do you guys really want to go through the other ones? Okay. Well, if you yourself go through some of the other ones and you have a question like, well, this is my answer, but I'm not really sure whether that is correct or not, you can always contact me and I'll take a look and tell you, what I think of your answer. So there's always that. Okay, so it's not like I'm abandoning this practice test. I'm just saying that I think we have covered enough of the test so that you guys understand the concepts involved in this particular exam. All right. Well, I like those questions. They're well thought out. What are some of the most common mistakes? I can't really single out one. I think most of the people who lost points, is because they don't read the questions very carefully. I'll give you one. A lot of people totally ignored the requirement that we want to make minimum changes. So what do you think they give me? Every single time I ask for a bijection, they give me exactly the same solution for f0, x0, and y0 as a bijection. Every time I ask for a surjection but not an injection, they give me the same set. Every time I ask for an injection but not a surjection, they give me the same set. And basically, the solution, f0, f1, and f2 that they give me have absolutely nothing to do with what the question has given them, because those people have completely ignored the instruction to optimize and do the minimal changes. So that hurt quite a few people in spring 2021 because some people decided I got a smart way to answer these questions really quickly. Yeah, that might be quick, but there's not a whole lot of points left. All right, so let me get back to the text channel. Uh, yeah, misreading, not so much. I think people are they're trying to do it too quickly, and they are skipping over some of the more important portions of the questions. So that might be one. New sets. Yeah. Basically, they just go like, yep. I'm going to use exactly the same sets when I ask for bijection and another set for surjection and another set for injection, but not a surjection. So every answer look identical, and they have nothing, absolutely nothing, to do with the F that is given. Um, is there a place we can get specific examples to try from each module in addition to these? Going over these has really helped cement some things I was not clear about. Hmm. Mm. I'm guessing you want a different type of question, not exactly the same type, just different randomized, sets, because that's really it's not going to help too much because you're just going to redoing the same thing. I think I will try to see if I can find some older tests because if I dig up the older tests, I have to give you the key too, and I don't always have the key to some of the older tests. So that's the thing. Uh, Yeah, there's some old problems, but they're too old. They're too distant from this semester. So I tend to look at what I asked in the previous semester and then I change a little bit of the way I ask the questions. Um, in other words, you're almost guaranteed that you're not going to get the same type of question as any of the previous exams. Um, how did they spend the rest of the time? I don't know. Yeah, the share folder is in Canvas. If you go to Canvas, all right, so if you go to Canvas, go to the class shell, and here is the share folder. Once you get to the share folder, there's X1, everything that has X1 is exam 1, everything that has X2 is exam 2, and everything that has FX is the final exam from the past. So this is from 1/6 is 2016. A 9 means it's a fall, a 3 means it's a spring. So that's how these files are named. Some of these have answers, and some do not have answers. But I don't really want to have to go through more additional um, past exams, because otherwise we won't have enough time to cover the material that we need to cover. So I would say, if you guys want to work on some of the older problems together as a group, that is okay. But I would say, don't count on me to give you the keys and have the keys explained, because we only got so much class time. That's the issue. The other thing, I'm not really sure how people study. The way I study is I try to see if I understand the concepts or not. So I basically try to drill everything down to the core and ask, okay, am I getting the idea? And having someone to bounce off ideas, is going to be helpful. So you can basically go like, okay, this is what I think this concept means. Okay, test me. Okay, and the other person can now generate, a little, tiny little examples to test you. Um, because the concepts that we are talking about are fairly common, so you probably can even find tutorials and explanations on the internet if you just look up the names of those terms. All right. Are we? Is time is? Oh, okay. I see. Time is up. Alrighty. So we'll talk about new topics on Wednesday. If you need clarifications, of some of the concepts, we can talk about that a little bit, but I would not give you additional practice test. But you can reuse, use any one of these for your purposes. All right, cool. And Tosh is still typing, so I'm gonna wait until Tosh is finished typing before I sign off. Oh, okay, cool. Thank you. All right, so I will see you guys on Wednesday. But I do have office hours every day, so you can use my office hours if you do have specific questions. All right, so I'm gonna sign off and stop streaming. And here is a goodbye from the cricket.